Hey everybody, Anthony here, and today, light on the Python, I'm afraid. So we're actually going to look at, I guess, I don't know, slightly more mathematical concepts. In Nuke, we're going to look at the idea of NaN, inf, and in general, large numbers. So we'll go up to infinity, and if we've got time, we'll sort of stretch it a bit further. Right, so the first thing is obviously to build a rig so we can look at it. Like, what do these things actually mean from a Nuke perspective? So let's actually do that. I'm going to put down a checkerboard. I have this at 256 square just so you can close that, just so it's a little bit smaller here. We don't need a huge amount of detail. We're just going to do some brutal work. I'm going to put down an expression node, and the expression node's great because we'll use it at the very end for a much more useful purpose, but I can just type values in here. So let's set the red channel to be let's do not a number, a NaN. NaN stands for not a number. All right. So you notice the image has changed. We'll loop back in a second. But anytime you see NaN, don't think of it as big, small, strange. Think of it as penguin. It's not a number. It makes no sense. It's penguin. For the green channel, we'll use inf for infinity. Obviously, we're directly updating it. And on the blue channel, we're just going to pick, I don't know, we'll pick something that's large. It's not infinity because we can represent it, but it will be large. So one with a few zeros behind it. Now, if I sample this area, you can actually see, I'll just sample this region. You can see the readout here. The blue is very hard to read on the black text, I'm sure, but the red channel is NaN, the green channel is infinite, and the blue channel is just huge. So what you'll immediately see is green, let me swap those around quickly actually. I'll make the red channel large and this one to be NaN. Yellow is a mix of obviously red and green. So Nuke is able to display the large value and infinite value. It gives you some sort of color. But blue here is NaN, and Nuke cannot display penguin. I mean, it doesn't know what to do with it. So anytime you have a NaN value, it will just simply, look at blue, it's just going to be zero. Sorry, it's not going to be zero. It's going to look like it's zero because it cannot figure out how to display it. It's the same idea as if you have an EXR and you have something outside the bounding box, who knows what it is. You have certain specific things you have to do. It's either black outside or you stretch the edge pixels. So yeah. NaN is represented in Nuke by the absence of displayable information. Whereas, go back to the three-color view, large numbers on the red channel and the green channel with infinity are just displayed as best as it can, which generally means as high as you can go. You might have a viewer process here that will attempt to manage them. We'll demonstrate later where large numbers are painful, but you can deal with them. Infinity tends to break everything. Right, so that's the implications of the display. So already you'll notice without sampling, you won't easily be able to tell the difference between an infinity value, which is the green channel, and just a humongous value, which is the red. Right? So that is the idea of, I guess, infinity. Now, infinity is, I've mentioned it a couple times, it's just a really big number. Right? So question you might be rolling through your head is, how big is this? Like that's still a very large number. If you got a render with something that is that hot in it, probably want to fix that render or do something with it. So slight segue. Nuke is internally, within all of its channels and everything, a full 32-bit floating point environment. Why do I mention that? Because that kind of tells us exactly how big the numbers can go. So if you were to swan to the here we go, the Wikipedia page for a single precision floating point format. We're in a, remember, 32-bit floating point values. So your red, your green, your blue, your alpha are all represented by quite a large amount of data. So let me select this thing. Here we are. An IEEE 754. I have another video on floating point representation. I'll link it a bit later, but not important for this. A 32-bit base 2 floating point variable, read that as number, has a maximum value of 3.4 something 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 times 10 to the 38. So let's actually take this expression node and sort of demonstrate how you can generate these values. So let's just copy that out. I will close that window. So let's go with the big number. We know it was e to the 38, right? And you'll notice that e to the 438, the red is gone. Oh, well, that's big. I can do that. That is big, but I can represent it. We'll take that one, we'll replicate it 3 times. So it's white because they're all big values. So here, let's just make it slightly bigger. You'll see immediately that this has gone to infinity, right? Infinity in this case means that it's bigger than it can internally represent. For a floating point number, there are ways to encode the concepts of this is infinity and this is penguin, or not a number. So that's what we're taking advantage of here. The last thing I was going to do here quickly is that you can, oh god, I'm just trying to find my notes. So I actually wrote a script for this thing. Oh yeah. And on here, the other way you can look at it is you're just trying to make a large number. So here's the distinction. 1 divided by 0 is infinity, right? So that's another way you can make a gigantic number, because anything divided by 0 approaches infinity. 1 divided by a tiny number is, oh god, I'll put it on the I'm going to put it on the green channel. You can just read that easily. Is a large number. So same kind of idea. Infinity is huge numbers. There you go. And now we've hit infinity. The other interesting thing to consider is that infinity is still a number-like concept. All right. So here we'll use. Really hate the fact you can't read the blue channel effectively. Let's just completely ignore the blue channel. Right, so treat the first if. So we've got red and green. Red is infinity, green is nan. All right, so infinity as a number-like concept does allow you to do something like negative infinity. Negative infinity is a thing, just like you can have negative values for your channels. For example, you might be looking at noise sampling and some other stuff, but you can actually have very large negative numbers. That's totally legit. So positive and negative infinity is a thing. Nan, as penguin, makes no sense. So negative nan is not really a thing. So, you know, that expression I have here just makes no sense, because you're trying to do math-like operation on something that like doesn't fit into the world. I mean, there's a lot of interesting stuff around in the concept of infinity in a mathematical sense, but nan is just, it's a representation of this can't exist, right? So this is probably the beginnings of getting into the math side of it. But one thing, let me reset this so I can show you. So inf. All right, so we've got positive infinity on red, nan value on green, and blue is just 0 because no one can read this sampling value down here. Totally fine. So I mentioned that Nuke internally is a full 32-bit environment, so you can do all this kind of jazz and you're fine with it. Cool. So let's make, let's actually make blue a large number. So what's that? 3.40. Let me just find it. That value 3.0 e plus 38. All right, so that's a yeah, trust me, basically the blue is a large number. We know that internally within Nuke we can represent it, but it is a very large number, right? So that's fine. What happens when you write it out to a file? And so this is the other thing you have to consider. So if you're getting renders, they're probably going to be 16-bit EXRs, or you'll use that because not everyone needs 32-bit data. You may need 32-bit data for your for your AOVs, your world position passes, your normals, everything that's actually representing more than a pretty pixel. It's actually technical information. That precision may be important. So let's actually see what happens if we, sure, let's just save it here. No, I do not want to overwrite that. What do I want to call this? Precision.exr. So let's do a couple. So I'm going to do a 16-bit half, and we'll just do one frame. We'll do a 32-bit float. Now, 16-bit half float, 32-bit full float. Right, so they're both floating point. So we'll render that out. Yep. and we'll also do a, let's do a 16-bit PNG. Render. All right, so we've got 3 different files. So let's bring all of them in. That's the PNG, and this is the EXR, and this is the 32-bit EXR. All right, let's see what we actually have here. So first is the obvious one, the PNG. That's going to be simple. So PNG here, if you let's actually use 2 viewers. I set this top and bottom rig for a reason. So viewer 1, the top viewer, is our source image, so it's our expression. Viewer 2 is our sample, right? So let's examine what's happened with the PNG. We've written out a 16-bit PNG. PNGs in this case are integer based. They're not a floating point format. The red channel started out as infinity. What has this PNG given us? Well, its concept of infinity is 1. It is maximum value. It's the hottest that the PNG can sort of store. I think infinity just sets every bit of the integer value to maximum. NaN is the green channel. NaN is just a strange 1.2. It's a tiny value. I think that's meant to actually be 0, I think, but it, again, has no clean way to represent it. The blue channel is another example. The blue channel here is just a big value, 3.4 e to the 38, and it's represented as 1. It's treated as infinity as well. So that's an integer format, which is why we don't like it that much. So let's have a look at, let's go for the next thing is the 32-bit one. All right, so the 32-bit one's now at the bottom. We had inf, nan, and a big number. We still have inf, nan, and a big number. So no surprises there. We were working in a full 32-bit floating point environment. We've saved it out as a full 32-bit file. Same. This is the interesting one. Let's have a look at the 16-bit image. Inf, nan, big number. Inf, nan, inf. Inf and nan are both one-to-one representations. You can represent it because it's just a particular value that means infinity. One for nan, it's a particular value that means penguin. But 3.4 to e to the 38 is too big for a 16-bit half float EXR. So in the same way in our expression node here, when we went bigger than this number, it went, well, I can't represent it. It's bigger than anything I can possibly do. Therefore, it's infinity. So that's what's actually happening with your files here. So just bear that in mind. You shouldn't, I can't think of any good reasons why you'd be dealing with anything this huge, but this is what happens if you do infinity and so forth, right? So to cap off the, I guess, the theoretical side of it, we're actually going to look now, just to close it off, at infinity and NaN maths, which kind of makes sense, but may not intuitively make sense. So let's get rid of this viewer. We're just going to use this particular one here. So the expression node is setting our value, so it's infinity, nan, and large. We don't care about that. I'm just going to make it 0. Yeah, that'll do. Sorry about the pink. It's not my favorite color, but will do. It'll do. So we're going to use a grade node here. The reason we're going to use a grade node is and don't forget take off black clamp, because that is, yeah, all right, cool. We'll need that in a second. So we're going to use multiply and offset. So multiply is literally multiplying the value. So we're going to check multiplication, and offset we're going to just use as addition. So nan with anything is still a nan value. So it's inf, nan, and 0. So if we offset it by any value, you can watch the blue actually changing, like, sure, it's still a nan, right? If we multiply it by anything, so we can multiply it by -1. -1 affects the infinity value. It's now negative infinity, but the nan is still unchanged. And also, if we just go here, so other operations, if we 0, actually, I'll do that one separately. Nan times 0, you saw, was still a nan. Nan plus nan is still a nan, and you notice everything is now nan. So pretty much any operation you do with a nan results in a nan. It doesn't matter what the second thing is. So let's say you've got two images and you're doing a diff, like a merge difference between the two of them. NaN pixels on the first image, or the A stream or the B stream, you're doing A minus B. So that NaN is going to, well, it is going to contaminate everything. So pretty much anything involving NaN pixels results in a NaN pixel, right? That's just how it works. Infinity is more fun though. So let's go back to here. So infinity plus infinity is still infinity, right? Infinity multiplied by anything is still infinity. Two lots of infinity is still infinity. Infinity multiply, you saw that one already. Infinity times minus one or negative is infinity, right? So those are the simple, straightforward kind of things here. What about if we have the blue channel is 0? What happens if we divide it by there's no divide here. I'll just go into the expression node. 0 divided by 0 is not a number. So that is insanity. 0 on 0 is not a number. There's a possibility you might be going 0, anything divided by itself is 1. No. 0, anything divided by 0 gets you into weird territory. Right. So 1 divided by 0 is infinity. A small number divided by 0 is still infinity. Right, so that's another special case. Basically, if you divide by 0, you get infinity, unless you're dividing 0 by 0, in which case you get something that's insane, not a number. What else is interesting to show? So infinity plus infinity, we know is still infinity. Infinity minus infinity is nonsensical, right? So what we're doing is we're saying in infinity minus infinity is what is it? Is it 0? No, because infinity on one of the infinities could be bigger than the other. How much? We don't know. It's an undefined amount. So infinity minus infinity, or if you prefer infinity plus infinity, is nonsensical. Therefore, it's not a number. The other, but if you have, oh god, this is going to confuse you. If you have negative infinity minus infinity is still negative infinity, right? Because that's just a variation of multiplying it. So that's also an interesting, I'll set that back, an interesting result. The last thing, which is going to be possibly confusing, is here. Multiplying infinity by 0 should give us a NaN, because an infinite amount, 0 lots of an infinite amount, undefined. Right, so that's sort of a basic run through of inf and NaN maths in Nuke. Right, so this is the theoretical foundation for all this stuff. So let me clear the screen quickly and I'll pull up a rig that I built. I'll attach it and you can have a play with it. So this rig is not as exciting as it looks. I've done it in probably a way I'd consider a little bit more brain dead than usual, but I've done it so you can explicitly see what's going on. I've got a constant. These constants are just giving me my size, so they're all whatever it is. I've got noise, which I've just shoved onto the RGB channels, and all the noises are different Z depths, and they're not animated or anything. And then I've just slammed them all together. I don't care about the alpha channel. And then for the expressions, I've got this little guy here. I've just said, if it's above a certain threshold, if the red is greater than 0.7, make it infinity. If the green's higher than so forth. So we can have a, and I've just done a over, probably should have done a plus actually. Change that to a plus, there you go. So what I've done is I've gone, this is making NaNs, and this is making large. So what we have here, and you can grab this and use it yourself, is an image which is, what happened there? Oh, there you go. So you have an image which is sprinkled with stuff. There are int values here, there are NaN values here, and there are also very large values here. and you won't be able to tell by inspecting it. It's just got stuff. So let's see if we get lucky. This green pixel is infinity. This green pixel is just large. There is also a red value of nan here. This red value is infinity. This has a red value of 0. So this is kind of like a form of a torture test. So I'll let you explore it yourself, but I've got 3 things here. So this is an expression node, which shows the isNaN call. So basically it's saying if it's a nan value, just set it to 1, otherwise set it to black so you can detect the nans. This one is the same concept using isInf, right? So you can change your view here. You can see which are the infinite pixels and what channel. There's some blues here. You can tweak it and change it to your heart's delight. The last one I've got here is this blur. So I have keyed the size of the blur. So remember I have nan, inf, and large values on this thing. So what happens when you apply blurs and things to these values? You get some interesting results. Let me set this to none. Right, so I've set this to none, so there's no viewer process stuff going on here. So if we just scrub this through a little bit, right, everything's going a little bit strange. Some of these, but eventually all these values end up as nans, because every time you have pixel operations, the nans keep getting bigger and bigger and bigger. So hopefully this will be useful. You'll just see, this is not what you expect to see. It's just getting silly, not from a blur. All the colors will blend into each other. This is, why is that yellow? Why is it displaying that? Let me just force this to reload. No, at this point, I really don't trust it because it's saying nan yellow, nan green gives me yellow. Oh god. Okay, so the way in which it's just showing it is dependent on your viewer process, which kind of makes sense actually. Yeah, this will explode in various interesting ways. Anywho, that's sort of the I guess the bonus side of it. So this is a very common problem here. You'll get renders with pixels that are blown up for various reasons. It might be the renderer has tried to calculate something that it just can't calculate and it's gone, it's big. Or if it's tried to calculate something, it's gone, it's penguin, and giving you nan values or infinite values. Totally fine. You would just have something like this expression node here or this one to detect them. You can also do this through Blink script if you're feeling like playing with that stuff. And you would also need to deal with, well, this pixel here, this is the nan pixel, so it's not a number. What do you want it to be? So there are various things that I've seen people do. It's like infinity values are probably really bright highlights on something, so you just take the surrounding pixels and sort of backfill them in. So an example of that would be you would use this guy here and just say this is my alpha. I'm just going to cheat. I'm just going to say if any of the red channel is infinity, then this is the alpha mask. So all these dots, and you just you'd blur the source image, assuming the source image didn't have a whole bunch of junk like we've got here, and then you would just use this as the mask to basically copy those values across, as a very primitive example. But that's one way to get rid of things. The other way you could just decide is for infinity. It's a nice simple one. Infinity just means super hot. You could define what your hottest value you want in your sequence is, and then you just say, if it's infinite, just set it to whatever your maximum value is. Like maybe you have a value like that. That's that's shot, not shot to shot. It's down to how you want to work with these things. So yeah, I guess less Python for a change. Since I did say this is Python script editor, so let me let's just throw this here. So all these commands you saw with isNaN and isInf, let's just do something on. All right, so let's just pick a pixel here. This pixel is inf. It is 118256 side, 565. So you can do stuff like this. Nuke to node merge 1. So at the merge 1 node, there's a sample called sample, right? And then you can see what the sample function does. And you can sample a particular region. So let's actually sample something quickly. So sample. So this one is a little bit messy. C is the channel name. I think the channel name is RGBA dot G, and then the X, Y, DX, DY. So the center of the area is, this always does my head in, 1182. The Y is 565, and we don't need a frame. Nope. Is it G? Yeah, okay. So you can sample channels that way. So you can build scripts to do this as well. If you're building an automated checker, you could just sample all the image to find out this stuff. There's plenty of approaches. You can actually take advantage of the fact, for example, NaN values pollute the image. So you could just, it's not the smartest thing I've ever done, but you could just blur the heck out of it. And if you just blur the heck out of it and actually, try that actually, I'm curious. If I reformatted this to a 1x1, by the way, I'm not suggesting this is a good idea. I'm just curious. Okay, so this is now a 1 by resize type width. Yep. Yeah, okay, cool. It's not clever, but it is kind of amusing. If you because NaN pixels sort of pollute everything, because NaN with anything is a NaN, reformatting your image to a 1x1 pixel will mean that if there are any NaN pixels anywhere, you're going to get NaN values on those channels. So if I just disable that, I think. Okay, no, that doesn't work because infinity is going to cause you some problems. Yeah, okay. Don't do what I just thought of. Because when we went through the infinity mass, if you do certain things, will cause also this kind of thing. All right, ignore that. I'll leave that in the video as an example of me musing about something that doesn't work. But yeah. So I guess that is some very primitive infinity and NaN maths in Nuke. This kind of thing here with these expression nodes, just build one, have a muck around with it yourself, and you will honestly see these things everywhere. Anytime you're bringing in CG from upstream or someone's delivering you CG, it's basically good form just to have some sort of inf NaN killer. Everyone has their own flavor of it, but they all come from that same base idea of locate the pixels that are a problem, and they will change frame to frame. Fireflies like to migrate, and then the artistry or the challenge is actually deciding what do you do with them, because it's garbage data you need to replace. Do you ask for a re-render? Do you patch it? Don't paint it out. You know, there's plenty of things you can do. So yeah, guess have fun with it, and I'll see you guys later.